Welcome to the world of 3D printing. In this video, we'll dive deep into how it works, its applications, and its future potential. 3D printing, or additive manufacturing, started in the 1980s. Unlike traditional manufacturing, which removes material, 3D printing adds material layer by layer. There are several types of 3D printing technologies, including fused deposition modeling, also known as FDM, stereolithography or SLA, and selective laser sintering, which is SLS. Each has its own unique process and materials. 3D printing is used in numerous industries. In healthcare, it's used for custom prosthetics and implants. In aerospace, it's used for lightweight parts. Even in fashion, designers are creating unique clothing and accessories. Recent advancements include bioprinting, where living cells are printed to create tissues and organs. Researchers are also exploring 3D printing in construction, aiming to build houses quickly and affordably. 3D printing can reduce waste by using only the material needed for the object. However, the environmental impact depends on the materials used and the energy consumption of the printers. The future of 3D printing is bright. Imagine on-demand manufacturing, where products are printed locally, reducing shipping costs and emissions, or personalized medicine, where custom drugs and treatments are printed for individual patients. 3D printing is transforming how we create and innovate. Stay tuned as this technology continues to evolve and shape our world. Artificial intelligence is revolutionizing the 3D printing industry. From optimizing designs to predicting material behavior, AI enhances efficiency and innovation. This chapter explores how AI is integrated into 3D printing processes, leading to smarter and faster production methods. Discover the synergy between AI and 3D printing and how it is shaping the future of manufacturing. Imagine a world where machines can learn and adapt, making decisions that improve the quality and speed of production. AI algorithms analyze vast amounts of data to fine-tune designs, ensuring optimal performance and material usage. This not only reduces waste, but also creates stronger and more reliable products. In the realm of predictive maintenance, AI plays a crucial role by forecasting potential issues before they occur. This proactive approach minimizes downtime and extends the lifespan of 3D printers, making the manufacturing process more sustainable and cost-effective. Additionally, AI-driven generative design is pushing the boundaries of creativity. By inputting specific requirements and constraints, AI can generate innovative and complex structures that would be impossible to conceive manually. This enables the creation of lightweight yet sturdy components, revolutionizing industries such as aerospace and automotive. As AI continues to evolve, its integration with 3D printing will unlock new possibilities and drive the next wave of industrial transformation. The future of manufacturing is here, and it is smarter, faster, and more efficient than ever before. Thank you for joining us on this journey through the world of 3D printing. Stay tuned for more exciting developments as we continue to explore the cutting-edge technologies shaping our future.